I am driving around a new estate, Aladdin Garden Village in Yates. These houses, they have not got even a 12 months. What's gone wrong on the new property that there is an electrical issue?
I don't know!
I think there's a story to it as well, like the builder gone or whatever, like what the hell is happening? I cannot tell you, but I hope I will be able to record because this will be a new one and it will be a bloody good one. See you soon. Well, here I am. This actually property is only a couple of years old. The problem we have on this occasion is the shower. Shower is tripping every time the client is using it. I show you what I think might be the problem and I'll just comment on what's there already. Shower is here. We're gonna remove the cover because what I'm planning to do is just remove the shower circuit from the fuse board so we might not be tripping the installation. That will be just so much easier. A brand new fuse board. Please be aware this seal could void your... Okay, well, if that's the case, let's not break the seal for now and see what we can do. Well, it's been 5 years now, actually, 2020. It may not be any warranty anymore, but I like the label, it's pretty good. So without opening the fuse board, we can test if the problem is on the shower load or shower supply. There will be an isolation switch for the shower right here. Only a few years old property. Look what happened to this radiator. Shocking, isn't it? Damp? Maybe this is a new deco. I can spot first massive problem with this shower. It's a good brand shower, it's Mira. These are very good showers. But problem number one is this head. This is the worst thing you can do to your shower, especially if you're running electrical shower. That is okay for a mains powered shower without instantaneous heater. The heater, when you turn it on and request hot water, the water comes from the top. There is a heating element on either side, and as it goes around the heating element, it comes out. If you ask for level 3, like the highest heat, it reduces that flow, slowing it down so it has more time to pass through, and you got hot water. But if you then further put resistance on that exit, that could actually in turn do two things. Right here, there is that DPM. If there is resistance, that breaks and there is a pressure that comes through that. And not damaging further the shower, is not like blowing up inside here, is actually doing that. And someone put the seal around. People don't do that. Shower is meant to be not maintenance-free device. We meant to be going into it, opening. Not. On certain models, you can remove the cover without undoing the water holes. On this one, you have to remove this. Okay, this is out. That was very loosely in. So what I want to do is, because there's a seal on the fuse board, I don't have to necessarily, I don't open it. I will remove the cables now. I can put the installation back on. If I can test my ZS from here. If it trips, that means there's a problem on the cable, not with the shower. And that's the quickest way to actually verify which one it is. If there is a problem with the shower, there's just a problem with the shower and there's not much we can do other than replace the shower. There's not many components we can replace here. We should start from the one that has no power, neutral that hasn't got any. Should be seeing voltage as it appears here. And it is 246, 246. So earth to life, yes, life to neutral is good. Let's press to test. And as it's testing, LCD has tripped. That's a bloody new one. So the question is it the RCD that there's a problem with? I wonder if this is actually the problem with the shower at all. We will need something else. I don't think this is a problem with the shower. I think this may be a problem with the RCD or with the earth leakage test. In that case, there is the warranty. So the shower's gone. What we're going to do is we will actually perform RCD test just to see if that RCD is all right. So I've isolated all the loads, but this is only in the load conductor, in the line conductor, not neutral. Neutrals are still connected. Let's lift this bugger up, carry out the RCD testing. Well, I just realized I will need probes. Crocodile clips are coming off. This goes onto the earth bar. We will need to do RCD tests. I only have ×1 and ×half, but because I'm in to test all of the RCDs, max auto start test, normal ramp, Yes, yes. Auto sequence customization. Yep. Okay, let's do auto sequence. Okay, that's what I want. And times 5. We don't need times 2. Cool. We're going to leave that. Okay, and go to RCD tests. So we will have 8 tests altogether. Half times 1 times 5 and ramp test. So we get a good picture of this RCD. This is the load side start test. This will trip 8 times, or it should trip 8 times. I have to redo my tests, because although I was testing times 1 times 5, the settings was EV or AV A-type RCD. This is an A-type RCD, as you can see here, A, and it has like the AC wavelength and a DC sign. We need to put A here. Let's redo our tests. These two should not trip when it's times half, because it's only half the rating, so it should never trip. It's inducing like 15 milliamps, and that's 30 milliamps RCD. So let's start. I hope you can see it. Okay, times 1, it went over 300 milliseconds. Why? People, you should press this button, that's very important. Okay, let's try this again. Yep, that's a good behavior. So is this one. Yep. I can see the numbers, it's 28.9 milliseconds, 28.8 milliseconds, and the ramp test, the one that we RCD trip test could not be completed. I moved my hand again, did I? Let me show you. It didn't trip here, it didn't trip here, that's good. 68.3 on times 1. That's okay. The maximum is 300 milliseconds. Then that one is 103.2 milliseconds and 180 degrees of the wavelength. Then we have 28.9 and 28.8 at times 5 the rating, and now we need to do a ramp test. Because I've done all the other one, I'm going to go to ramp test. Now just double check on myself. So this is 0 degrees on the AC, it's A-type, 30 milliamps, ramp test. Let's make sure I've got the probes in the right place. Start. Okay, 19 milliamps. That's what I was thinking about. If this is tripping at 19 milliamps on a 0 degrees, let's check 180 degrees. I think there's just a lot of electronical devices. Why would they install the dual RCD? Yeah, 19 milliamps. Why would they install dual RCD fuse board on a new build where we have problem with this RF leakage? And that's what it is here. This is a 30 milliamp RCD that only needs 19 milliamps to be tripped. Start safety protocol and disconnect, because there is a 19 milliamps of difference. What you're asking and what you're receiving, and that's it. It doesn't like it. It trips it. Why is it doing it? The RCDs are designed that the older they get more sensitive. So it works in a different way. Usually when something gets older, it gets more unsafe. With RCDs, the older they get, they will not tolerate as much as they would when they were brand new. They will tolerate less. This is for our safety. What client has narrowed it down to shower. I actually think this is something else, but what we will need to do is put these around the main tails. What we might have to do is isolate that side of the house, because we only want to read and listen to what's happening here. Let me ask the client to isolate the whole power.
A few moments later.
Always ask your client before you just switch off everything. You never know. They might be writing a novel and the Lord of the Rings might never happen again. Okay, let's put this light on. Cool. So we are now reading 0.03.2 milliamps, and it's just everything is going down. Nice and beautiful. Okay, cool. I'm now going to turn the RCD on its own. Again, it's just normalizing 0.06, nothing. We're looking for 19 and over. So these are the first one from the left, second floor lights and smoke alarm. That, ladies and gentlemen, has taken to 200. That's interesting. I've not seen a number as high as this, 200. Let's take this down. Let's put, second one is sockets. I've just put the sockets and it tripped. And remember, the shower is disconnected. Nothing is on. 4 breakers still down. It's just going down. 0.2. The second one is oven. 13, 11. The shower is actually not connected at all. Nothing particularly at fault right this moment immediately. Might be collectively the lights. It might be like these Chinese LED lights installed on the second floor because I'm getting a really high reading. Let me put these lights second floor and smoke alarms up and observe what happens. Goes over the limit and then just reads at 200. Why is it not tripping? It should trip at this moment. So let me show you what happens when I put the sockets on. It tripped. What happens if I just put the socket on their own? It gone over and it tripped. So it's not just down to the shower at all, because at this moment we can't even have the RCD on. We will go with the client and disconnect everything from the socket circuit. We need to find out if this is the bottom or if this is the top sockets.
One eternity later.
Shower has nothing to do. I think if anything, shower is the only one that might be good. It's a 30 milliamp RCD installed in every domestic scenario. Basically what it means is, for example, boiler at 6 amp. If you're asked for 6 amp on the brown one, on the blue one, which is a neutral, it needs to come back 6 amp. RCD, its role is, if there is anything different than 0.003, it doesn't like it. But that's when it's new. Your RCD, as I tested, it's already triggered at 19 milliamps. Very common for properties. Collectively, on different circuits, there is a leakage. It could be devices that are, wearing off. Difficult to say in a new house like this, but usually the usual suspects are like a heating element submerged in the water. So for example, a kettle, water tank, a boiler, because you've got a heating element in the water that erodes and degrades over time, and is encapsulated into some kind of a metal earthed tank. Some of that energy goes into water and then it being picked up on the actual earth. If it's going somewhere else, it's not coming back. But here, it might be electronics. It could be lights, because there's a high leakage on your lighting circuit, which is the second floor lights and smoke alarm. And on your sockets, it's over the limit. I wonder if we just remove the alarms and see what happens, because right now I'm putting the RCD on. Yeah, I think there might be also a problem with the RCD. RCD doesn't even want to come on now, so yeah, there's definitely something dodgy going on.
A few moments later.
It could be down to one of these smoke alarms, which we go into firstly, look into the sockets. You see these lights are working, so it's nothing to do with these lights because they're on, so it's something to do with the lights maybe downstairs. It is very common that the sockets upstairs are with the lights downstairs. So these lights up here might be okay. Client mentioned something about the smoke alarm. So to speak, we're going to take this half of the house off. So RCD first, and now sockets. You see, it is absolutely nothing. So there was something the client plugged in, and that's what it was. We can actually find out what it was. Let's try lights. There's still something on the lighting circuit. It might be the actual smoke alarm. Okay, we are getting there. Mr. Klein, whatever was on his sockets, it's not there. So what we're going to do in a moment, you're going to go back and put the stuff back in. I will be at the fuse board and I'll shout when I will tell you this is it. So at least you will know which item is causing the fault. Just a moment ago, when we only removed the ground floor and the first floor landing, we went down from 200 to 69 milliamps. Now we are down to 4.75 milliamps, which means, yes, it were the smoke alarms. Yes, it was something else. We won't put the smoke alarms today. I think we need to replace them. I think these are the ones that I would recommend are. We never had any issues with these ones. Now, would you help me, please? Would you go back on all the steps we did? And I will try to shout not too loudly as not to scare your child. Cool. So client is going now around the house to put this stuff, and just watch with me what happens. And we are only looking at the sockets at this moment. Hello, what was that, sir? That was it. That was it. Let's go and check. What did we put on? Oh, lovely. Would you mind leaving the adapter off and let's continue? I'm going to go back at the fuse, but just keep the adapter with you. We are at 0. Yeah, please. Okay, 1 second. Let's put it back on. We are not before. Yeah, please carry on. Okay, that was... What was that, sir? Okay, that's just 8. So that one is not as bad, but it's 8 milliamps. It's not broken yet, if that makes sense. If we take that one off, please, that adapter That second one, so it's 8, and the client's going to remove that in a moment, and it should, yeah, it went down to 0. Good. Yeah, what was that, sir? Smell diffuser giving us 8 milliamps. Okay, that one. What was that, please? Okay, so we definitely know that these adapters are a no-go. Please, if you remove it. Okay, that one is 1 millivolt. So it's negligible, it's coming down, it's just some electronics is stabilizing, going down. So we could ignore the socket doorbell. Okay, this one. What was that, sir? Okay, that LED light, has something happened to it as well. Okay, would you tell me what was that now? That's a lamp, that's 27. Yeah, wow. I've not seen this in any properties that that many items would have collectively a problem with leakage. That's stabilizing to 910. What is that, if you don't mind? That one may be bad. Maybe adapter. Wow. What could cause all of that air leakage issue? The electronical devices like computers, they are designed to leak a little bit of earth because this is almost the way they are checking the earth is there. The bad quality extension leads, your adapters, they definitely. I've not come across the property that would be only 5-year-old and so many things like smoke alarms would contribute to it. You're definitely top of the list, to be honest.